So I stated the problem in the earlier video. Let me prove it using induction. What is the base case? The base case starts with n equal to 3 and hence we have n square greater than 2n plus 1 where n equal to 3 will be 9 greater than 7 and hence the basis step is true. Let me move on to induction hypothesis. What do I assume? I assume that k square is greater than 2k plus 1 for some integer k. Positive integer k should be. So this is the induction hypothesis. Now, if this is true, that if k square is greater than 2k plus 1, then I should prove that k plus 1 the whole square is greater than 2 into k plus 1 plus 1. So, let me take k plus 1 the whole square. K plus 1 the whole square using the identity a plus b the whole square goes like this, k square plus 2k plus 1, right? Or I can also just rearrange them and write it as k square plus 1 plus 2k. Now, observe something very carefully. What can I write k square to be as? From the hypothesis, it is k square is greater than 2k plus 1. Now, I write it as this is greater than 2k plus 1 plus 1 plus 2k. 1 plus 2k remains as it is. Now, this expression is equal to, if you remember, I had explained when we write an equal to sign and when we write greater than sign. I am not going to touch greater than here. It is not affecting the inequality. I am just telling 2k plus 1 plus 1 plus 2k, this is equal to 2k plus 2 plus 2k. But the inequality remains as it is. Clear? Now, where did we start from? We started from k greater than or equal to 3, right? That's how we had started as the basis step, if you remember. Now, let me just substitute 3 here. Why am I doing this? You will get to know later. I'm going to substitute 3 for this k only. Again, why? You will understand in the next few steps. Now, 2k plus 2 plus 2 into 3. 2 into 3 is 6 plus 2 is 8. Now, k can take any value greater than 3 and hence this is greater than or equal to 2k plus 8. This is the most subtle part of this theorem. You might need to take some time for understanding this portion. This is 2k plus 8. Now, and this is greater than, strictly greater than 2k plus 3. Now, you can ask me, why did you write 3? You can also write 4 or 5. Yes, but we are concerned only about 3 here. Just observe the proof. So 2k plus 8, this is greater than 2k plus 3. Now what is the inequality? What is the status of the inequality? K square plus 1 plus 2k is greater than 2k plus 3. We are right now in this position. Now this can be written as 2k plus 2 plus 1. I'm just expanding 3 as 2 plus 1. Now, I'm going to take out 2 common here and this step is equal to 2 into k plus 1 in bracket, plus 1. So, now what is the status of the inequality? It is k square plus 1 plus 2k is strictly greater than 2 into k plus 1 plus 1. So, k plus 1 the whole square is greater than 2 into k plus 1 plus 1. We have reached the end of the proof. Take some time to understand each line in the proof. You might need to read between the lines and understand the proof.